Voice over Internet Protocol, VoIP, also referred to as IP telephony, encompasses various technologies utilized predominantly for voice communication sessions via Internet Protocol, IP, networks, such as the Internet. VoIP allows voice calls to be transmitted as data packets, supporting different methods of voice communication including applications like Skype, Microsoft Teams, Google Voice, VoIP phones, and traditional telephones connected to the Internet through analog telephone adapters, ATAs. The wider concepts of Internet telephony, and broadband phone service denote the delivery of voice and other communication services, such as fax, SMS, and voice messaging over the Internet, in contrast to the conventional public switched telephone network, PSTN, also known as plain old telephone service, POTS. VoIP technology has advanced to integrate with mobile telephony, incorporating voice over LTE, VoLTE, and voice over NR, VO5G, enabling seamless voice communication over mobile data networks, expanding its role in modern mobile infrastructure, particularly in 4G and 5G networks. The steps involved in originating VoIP telephone calls are akin to traditional digital telephony, including signaling, channel setup, analog voice signal digitization, and encoding, with transmission occurring as IP packets over a packet switch network, leveraging media delivery protocols to encode audio and video streams using codecs tailored to various application requirements and network bandwidth. These codecs, such as MDCT-based AAC-LD used in FaceTime, LPC MDCT-based Opus used in WhatsApp, and LPC-based Silk used in Skype, optimize media streams with speech coding standards in VoIP, predominantly based on linear predictive coding, LPC, and modified discrete cosine transform, MDCT compression methods. Early VoIP service providers mirrored legacy telephone network architectures in their business models and technical solutions, while second-generation providers like Skype established closed networks for free calls within private user bases, although limiting interoperability. Third-generation providers like Google Talk embraced federated VoIP, facilitating dynamic interconnection between users in different Internet domains. VoIP not only operates on VoIP phones but also numerous personal computers and Internet access devices, allowing calls and SMS via Wi-Fi or the carrier's mobile data network, providing a unified communication system that consolidates modern communication technologies. Moreover, VoIP technology's integration into mobile networks has led to the development of advanced systems supporting voice communication over modern data infrastructures, exemplified by voice over LTE, VoLTE, and voice over 5G, VO5G, directly connected to mobile operators' infrastructures for seamless connectivity to the international telephone network, with VoLTE and VO5G optimizing voice communication over IP-based mobile infrastructures, maintaining compatibility with traditional PSTNs for global connectivity. Protocols crucial to VoIP include SIP, H323, MGCP, H148, RTP, RTCP, SRTP, SDP, as well as less complex protocols like MGCP and SIP, leveraging their functionalities for successful VoIP communication services. In the consumer market, VoIP services leverage existing broadband Internet access for telephone calls, offering inbound and outbound services with direct inbound dialing, often including unlimited domestic calling for a flat monthly fee. Implementation of VoIP services can be done through dedicated VoIP phones, analog telephone adapters, or soft phone applications on networked computers, enabling a range of connectivity options. Telecommunications providers increasingly utilize VoIP telephony over dedicated and public IP networks, known as IP backhaul, to interconnect switching centers and other telephony network providers, promoting seamless communication avenues. Businesses are turning to VoIP systems from traditional copper wire telephony for bandwidth efficiency and cost savings, with VoIP backbone networks designed to support various communication types over a unified platform, dramatically reducing infrastructure costs while offering enhanced features. VoIP solutions, particularly for businesses, have evolved into unified communications services, treating all communications units as discrete entities deliverable through any means and to any handset, catering to both medium to large enterprises and small to medium businesses. The provision of VoIP telephony systems to organizational or individual users can be categorized into two primary methods: private on-premises solutions and externally hosted solutions by third-party providers. On-premises systems resemble traditional PBX models connecting an office to local PSTN networks, while the market trend leans towards cloud or hosted VoIP solutions, which are more suitable for smaller or personal deployments where a private system may not be feasible. Hosted VoIP systems involve service providers hosting the telephone system within their infrastructure, usually in data centers geographically close to end users. On the other hand, private VoIP systems, like asterisk-based PBX for small businesses, reside within the organization's infrastructure, offering benefits like QoS control, cost scalability, and enhanced security. Private systems can be physical hardware PBX appliances, converged with other infrastructure, or deployed as software applications, often in a virtualized environment. In terms of connectivity, on-premises systems mostly connect through LAN for local endpoints or using secure private links for remote connections. The quality of service in VoIP communication involves challenges like latency, packet loss, and jitter due to network reliability compared to circuit-switched networks. Implementing QoS mechanisms like diffserv can help minimize latency and prioritize voice packets for better performance. For integration with traditional PSTN networks, VoIP systems use media gateway controllers to connect digital media streams, with interfaces for linking calls via VoIP and routing through standard PSTN networks. Number portability is a crucial aspect impacting VoIP businesses, requiring adherence to regulations for subscriber mobility between carriers while maintaining number mapping databases to ensure seamless call routing. As the enterprise VoIP market expands, considerations like least cost routing, LCR, and mobile number portability, MNP, add complexity to call routing and demand a higher level of reliability in handling voice calls for VoIP solutions to meet the evolving needs of users. Fax over IP, FOIP, has faced challenges due to voice-centric codecs in early VoIP implementations. The timing of modem signals was hard to maintain in packet-based networks until the T38 protocol was introduced. T38 compensates for differences between traditional analog communication and packet-based IP transmission, ensuring reliable fax delivery over IP. Devices supporting T38 can connect directly to network switches or routers. Powering VoIP devices requires electricity, unlike analog phones that operate independently of local power. To address power outages, some VoIP service providers offer battery-backed equipment for uninterrupted service. Industry interest in VoIP grew in the 1990s, leading to the development of protocols like H.323 and SEP. Factors like open-source telephony software and the proliferation of high-bandwidth internet connections accelerated the adoption of VoIP services. Milestones in VoIP history include the proposal of LPC in 1966, the development of VoIP applications like Speak Freely in 1991, and the introduction of the SIP specification RFC 2543 in 1999, among many others.